If we combine the learnings from both the first law and the second law of thermodynamics, we would understand that the efficiency of an energy system cannot be greater than 100% for two reasons. A. Because the energy cannot be created out of nothing, and B. Because the entropy or the disorder of a system always naturally increases, and therefore any power system will always have less than 100% efficiency. Over history, there have been some fantastical claims that there are methods by which energy can be produced at no cost at all. People make these claims about electrical generators that run without any input, cars that run on water, and many other machines that would run without any fuel. These claims are always false. They are never proven. Often, if the inventor does come up with a working model, it is using some form of energy that the inventor is not telling about or doesn't know himself. Very often, the inventors will claim that the big energy companies want to hide this technology because it will ruin their business, as everyone will be able to produce their own energy for free. Well, it's true that the energy company do want to make money and often do not act in the best interest of the customer. However, this does not mean that the fundamental laws of physics can be violated. And moreover, no energy can come out of these systems. These inventions are often called perpetual motion machines, or PMMs in short. There have been over time thousands of such failed inventions, and this really goes to show the lack of awareness of the fundamental laws of thermodynamics, because if people were aware, there wouldn't have been attempts of making these PMMs in the first place. And therefore, the next time when someone proposes to install a wind turbine on the rooftop of your car to, let's say, get electricity that would power the car itself, then you should be able to explain that by installing a wind turbine on the car roof, the drag would increase substantially. And this means that you would be burning much more fuel to overcome the drag force compared to the energy that you would get from the turbine itself. Even when the car is moving, you would get less energy compared to the energy that would be required to overcome the drag force. And therefore, the overall system efficiency would always be less than 100%. Having said that, we have systems like the heat pump, where we input 1 kilowatt hour of electricity and in return we may get 3, 4 or 5 kilowatt hours of heat. Now we have to remember that these systems are merely transporting energy from one source to another region. And so in the case of a heat pump, the 1 kilowatt hour of electricity input is the energy for transporting heat from a ground source or ambient air. And to distinguish such systems, we use the term coefficient of performance, or COP, rather than using the term efficiency. And we have to remember that the thermodynamic efficiency of a heat pump is also less than 100%.